All right, section 4.1, antidifferentiation. Antidifferentiation. Okay. So let's get a little definition down here. Okay, definition of an antiderivative. The official definition of an antiderivative is a function f is an antiderivative of f. Yeah, I'll explain that. A function f is an antiderivative of f prime on an interval as long as the derivative of f is equal to f prime of x for all x on the interval. Make sense? Yeah. Definite gives you an answer, and indefinite gives you the function. Yep, that's it. Okay, so the reason why we're learning antiderivatives, because we need to know them to be able to compute the exact answer for any of the definite integrals that we're doing, which then gives us the answer to all of those application kinds of problems, and we can do them without using the calculator. Okay, so what we have to be able to do is we have to be able to integrate any function. Okay, so we've already dabbled this in a little bit, and so I'm going to just make up a couple here. We're going to start off slow, and we're going to try to develop our own pattern. Now, this is an example of an indefinite integral. Okay, indefinite integral. The difference between a definite integral and an indefinite integral, you can see, doesn't have the limits. There's no numbers. There's no number here nor here. Okay? So when you see no number here and no number here, it's an indefinite integral. And the answer to an indefinite integral is a function. Okay? That might be worth writing down. The answer to an indefinite integral is always a function, where if you page back in your notes, we know that the answer to a definite integral is always a number. Okay? Okay, so to answer the question, what is the antiderivative of x plus 3, we have to figure out what function exists that if we took the derivative of it, we would get x plus 3. Okay, everybody thinking of it? Okay. Who's got an answer? Brendan, what do you got?
X squared over 2 plus 3x.
X squared over 2 plus 3x. Everybody right now take the derivative of that in your head. You get 2x plus 3. Okay. This right here is one antiderivative. How many antiderivatives are there who has a derivative of x plus 3? Infinite number. So how do we handle that? We put plus c on the end. This c is a constant, It's called the constant of integration. It even has a name. It is called the constant of integration. Okay? Because this then is a whole family of antiderivatives for the function x plus 3. Think about it. It's the family of antiderivatives. There's an infinite number of them for the function x plus 3. Okay? So now, that's the core. That's the basis of everything that we're going to do over the next couple of weeks. Now we're going to build our skills on finding the antiderivative of anything we can find. Anything we can get our hands on. And then we're going to try to look for patterns. Okay? So let's do another one. So let's do x squared minus 2x plus 5. Notice it's an indefinite integral. We're not using the fundamental theorem of calculus. The answer is going to be a function whose derivative is that. Okay, who's got an answer? Mackenzie.
1/3 x to the third minus x squared.
Minus x squared?
Yeah. Plus 5x plus 3.
How many people came up with that? Sweet. Okay, this is correct. If you find the derivative of this thing, okay, the answer is this function. Okay, that's how this works. The whole goal of an integral, that's an indefinite integral, is to find the function whose derivative is that we're finding the integral of. Okay? Now, it'd be really cool if we could find some sort of pattern that would make this work. Follow me. Bitsy, you got something? Raise the power and divide by the power. So if we said integral of x to the 16th, x to the 17th divided by 17 plus c. Does that work? Can we find a case where that doesn't work? What about this one? What would this rule do if we had this? Follow the rule. X to the what? I'm going to write it out. Notice it's negative 2 plus 1. She said add 1. And then divide by that. Negative 2 plus 1. Okay, I'm going to just simplify this. This would be x to the negative 1 divided by negative 1, right? Plus our constant. What is this answer in its simplest form? What's x to the negative 1 divided by negative 1 in its simplest form? 1 over x negative 1 over x. Okay? So everybody see algebraically that x to the negative 1, we bring that down, raise the first power. The negative 1, I can really basically bring it up, so it's negative 1 over x. Okay? On your paper right now, find me the derivative of negative 1 over x plus c. If we get x to the negative 2, then we've got a good thing going on here. Go do it. Find me the derivative of negative 1 over x. We spent the whole semester on derivatives, so don't feel bad if you don't know how to do it. It only makes up half the AP test. Half the AP exam is on derivatives, half of it's on integrals. Look at it carefully. Everybody's got to do it in your head. Right? We're just using a power rule here. Power rule, negative 1 times negative 1, x to the negative 2 by subtracting, and we get this. The derivative of the constant is 0. And there we go. And, this said x to the negative 2. Yeah. But this can be rewritten as x to the negative 2. So I think we got something here. Okay? So let's write a rule. So the rule, and this is for polynomials. Okay? Rule for polynomials. We'll say the integral of x to the nth dx equals. We're writing our own rule. Anytime you come across anything where it's x to the nth, any number, what does this end up looking like? Go ahead and try to put it down on your paper. Then we'll put it up here and we'll see how you did. Okay? This side, somebody, what'd you get? Jenny. Okay, so you can write it a couple of different ways. If you say, well, it's 1 over n plus 1 times x to the n plus 1, don't forget the constant, then that's okay. If you wrote it like this, x to the n plus 1 over n plus 1 plus c, that's also okay. Okay, either one's fine. So that means we can handle anything that looks like this. So let's do a funky one. Let's do x to the 4th minus 5x cubed plus 2x to the 7th minus x plus pi. Okay? Integrate that. Follow the rule. We agree? How do you know you're right? Find the derivative of it. So you already know all the time whether or not you're right or wrong because you just find the derivative of this to be able to get to the answer. Okay. Oh, so wait a second. This reminds me of a rule then. What if we did this? What is the integral of k dx? K is any number? Kx plus c. Right? What's the integral of dx? What did you say? X plus c. How can that be right? There's nothing here. There is something there. It's a 1. It's 1 times dx. So we have that. But wait a second. How do we know just to add the x? In other words, if I have the integral of 7 dx, how do we just know that from derivatives that that's got to be 7x, right? Does it follow the rule? Yes.
Oh my god.
Sorry, new favorite students.
You're on a diet, Mr. Johnson?
Oh. Shh.
He's eating carrots.
All right, class dismissed. No. Wait a second. This is a polynomial, okay? Does it follow this rule? I don't see any x's there. Does it follow the rule? X is to the power of 0. Watch, I'm going to rewrite this. This is really 7 times x to the 0 dx. Correct? And then watch how it follows. It's 7 times x to the first divided by 1 plus c, which is 7x plus c. So it still follows the rule. Make sense? Okay. So where are we going with this? Well, I want you to be able to do any polynomial, okay, whatsoever. So let's do a little bit more practice with the negative exponents. For example, I want you to do this one. 3 over x to the 5th. Give me the answer to that one. You may find yourself rewriting it prior to actually doing the integration. Write your answer in its best possible form with no negative exponents. And don't forget your constant. See it? Yeah.
It doesn't matter if the negative is on the bottom.
Bottom or the top. The negative can go upstairs, or it can go downstairs, or it can go out on the front porch. But it can't be in two places. Okay, so any polynomial, you're going to have a boatload of those. Okay, you knew it was coming. Stop and think. What is the integral of the sine of x? Bailey?
Negative cosine x plus c.
Good. Okay, everybody see that? The integral of the sine of x is the negative cosine. It's the opposite of what we had when we did derivatives. Okay, and what is the integral of the cosine of x? Stop, think. Yes. Sine of x plus c. Okay, so when I said, hey, guess what? You're not allowed to forget anything from first semester. This is what I mean. Okay, because we're going backwards on everything. All right. Your next assignment you can go ahead and get started on.